Hello and welcome to the lesson on area and volume for basic geometric shapes. So I can determine the area and volume for a variety of geometric shapes. So these are going to be some different ones. You're going to see some ones from the past. We will see a couple of new ones, and we'll sort of step our way through and how the formulas are developed. So some basic shapes. So we have our tent or our triangular prism here. Our area on that shape, if you want to label it as sort of our length, our let's go length, I guess, on the way back. We'll go width at the front, length. This is our height, and then that edge length there, that's our slant length, or S. So if I want to find the area of this particular shape, I've got the floor, or the base of it, which is length times width, plus I'm going to have my end pieces. So my end pieces, if I have a different color here, so it'd be that end piece and that end piece, and there's going to be two of them. They're going to be the same. It's a triangle, so it's 1/2 the base, so 1/2 W times H, and plus, then we're going to have three walls, three sides, and they're all going to be LS, because we have that is our slant length, and that's uniform all the way through, and this is our L. Actually, sorry, there's only going to be two on either side, not three. My mistake. So that ends up being a 2, and it's just going to be LS. So it cleans up a little bit. So you get length times width plus the 2 and the 1/2 are reciprocals. WH plus 2 LS. So there's the area formula for a triangular prism. All right. Now the volume. Volume's a little bit simpler. Volume of any 3D shape, okay, is always area of base multiplied by its height. So our area of our base is that green area that I highlighted here. So this is what we call the base, and that's the uniform shape all the way up. So if we can find that area, which we know to be 1/2 WH, and we multiply it by how deep the shape goes, that's our L value, we end up with WHL over 2, or 1/2 WHL. So those are the two formulas for that shape that you will need. And the box, that's our volume. Onto the sphere. I'm not going to really show you where that formula is derived from. I might be doing it as an investigation in class, but I'm just going to tell you that because it's a funny shape, it's one of those unique ones that a lot of times it comes from calculus, the formulas, that the area is 4 pi r squared, and the volume is 4/3 pi r cubed. And we've already seen this in the grade 9 course, so I'm not going to spend too much time on known or old shapes. All right, our friend the cylinder, again, the surface area. We know that we have two bases, so we'll be given a radius. So we're going to have two of them for top and bottom, and they are pi r squared. All right, and then we need the side area of this side area of the cylinder, and that ends up being the 2 pi RH is what it results in. Okay, and that 2 pi r is actually circumference. All right, that's our circumference. All right, so it simplifies to make it look a little cleaner. 2 pi r squared plus 2 pi RH. It doesn't matter to me what form you take here. And I've seen people that do it as 2 pi, take the common factor that out, and leave it as r squared plus RH. It doesn't matter to me which one you choose. You can just write down one. It's the one that makes the most sense, or it seems the most easiest for you to remember. Our volume, again, is area of base multiplied by height. So the area of our base is pi r squared, and multiplied by h, and we get our final volume of pi r squared h. So it follows kind of a common theme here. Okay. Surface area here, so this is, it's going to be a equilateral pyramid. So all these lengths are the same on the bottom. We're going to need an H, and we're going to need a slant length. So let's call the three equal sides length B. And we're going to go from there. So let's start with our volume formula. So volume, when you're dealing with a pyramid or a cone, it's always 1/3 the volume of a prism. So what that means is, if this was a regular prism, it would give us a tent, okay? So it would give us the tent shape. But instead it goes to a point, so it's going to be 1/3 of that volume, so it's 1/3 of 1/2 base height. So I'm just pulling from over here, WHL over 2, so 1/2 base height, and I'm just trying to, it's going to be our, so that's also going to be an H, BH, and I guess we'll go with L. We'll keep it consistent with that first page, so it's 1/6 BH and L. Okay. Now the surface area, because it's an equilateral, they're going to give you this L length inside here. So to find the area of this shape, I guess the easiest way to go about it is just picking it apart. So we know the base, we've got to find the area of the base. So it's going to be a length of, first of all, it's a triangle, so 1/2 B. And then it'll give you that L length through the bottom there. So 1/2 base times height, so 1/2 BL. Plus, and the three sides are going to be the same shape in this particular course. They don't really vary in terms of, we're starting off with sort of our simple shapes, so it's a little easier to see. So that S value is actually, and maybe I'll show it a little bit better down the side here, it's this length of the face. So S is actually the length of the face of the sides, so I'll get rid of that one. Okay, so when you look at or go to calculate that particular one, there's going to be 3 of them. It's still 1/2 because it is a triangle. This is B, and it's multiplied by S, so it's 3 times 1/2 BS. I'm sure everyone's having a good chuckle over that one. So we end up with an area formula. Looks like that. Oops. So there is your next formula to put in the cheat sheet. Now we move on to some interesting shapes, and I think what I'll do is I'm going to move down to the bottom and do the 3D cylinder, the prism shape, because our formula up here on top is going to depend on the one down below on the bottom. So on the bottom, we're going to have the side lengths are all equal. So we'll call that a B, for example. And we're going to break it into basically a pi. And those lengths are going to be the same for us this year. So I'm going to call that R, just for consistency, and a height. Okay? So let's start with the volume formula. Volume is always easier to start with. So we know it's going to be our base area, base area times height. So the base area, there are 1, 2, 3, 4, 5 triangles in this case, and they are triangles, so 1/2, and it's going to be B multiplied by that height. Maybe I kind of misrepresented our R. Our R will be the height, the distance from. They always give it to a side edge, so maybe I'll put it on the bottom here to make it a little bit more clear for you. So 5 times 1/2 BR. And we multiply it by the height. So our volume formula ends up being 5 BRH over 2. Okay, so again, that R measurement, that goes from the center of our 5-side shape to the edge, so the perpendicular distance. That'll be the measurement they do give you in the homework. All right, surface area then. We already found the area of the two ends, So there's two n's, and it's multiplied by 5 times a half BR. All right. Plus, and now when we're looking at this next, our sides, they're just rectangles. All right. And there are 5 rectangles. So it'd be 5 multiplied by BH. So just cleaning that up, the 2 and the 1/2 ends up canceling. So it's equal to 5BR plus 5BH. Oops. Or just take the 5 and BR plus BH. Doesn't matter which one you prefer. So there's your surface areas for that particular shape. So moving up, back to this one for a second, it's going to be the same information given. They're going to give you the height of the shape, and then, if I draw it properly this time, the distance from the center of the shape to the perpendicular edge. Volume is always 1/3 the prism. And that's why I did the prism down below. So I'm going to use the prism from below, and it's just going to be 1/3 of that formula we came up with, which is the 5BRH over 2. So we end up with 5BRH divided by 6 for the volume. So it's always easier to find that prism shape first. Now this is for a 5-sided object. You can see the pattern here if you have to develop a formula for 6-sided, 7-sided. You can see how it's done. It's the same process. Our surface area, well, we already know the base. We found it down here. Right along here, this formula here, you don't need to use my green lines here to mess up your note. But that was the base of the object. So this time there's only one of them. We don't need 2 ends of it. So it's back to that 5 multiplied by 1/2 BR plus, now the triangle sides, see if I can draw this properly, they're going to give you that, what we call S, that slant length down the face of the triangle. So there's going to be 5 of those. 5, and again, yes, you gotta like that, how that works out. So you end up with 5BR over 2 plus 5BS. Or, I just like saying the BS thing for you, because I know you're getting a chuckle out of that. You take the 5 out, and you can have BR over 2 plus BS. Alright, either way you gotta add BS. Don't forget about that. So there we go. So there are our formulas for some basic shapes. So I have an example here. Remember, this is a trapezoid, so it's the same thing. General rule, and I've already been talking about it as we go. It's basically area of a face, area of the uniform face, multiplied by its height or its depth. So if you think of this face here, so I'm looking at the front of the trapezoid, all right? If you think of it as like a card, there are how many different cards in this deck as you stack them up. So if you can find the area of that front face or the card, multiply it by how many cards you have, then you can determine the volume of any sort of uniform prism. So we know that from grade 9 and from your formula sheet that you have, it is for the area would be the height, which is not given here. So I'm going to quickly calculate that. So that height's approximately 3.5. I just used Pythagorean theorem there to figure that out. It's the point of the lesson is your formula is the height, then it's A plus B over 2 for the area times, I should use a different variable. Let's just call it, actually, we'll change this second one. We'll go to the length of the object. So I can still use the H. So the 3.5 multiplied by 10 plus 8 all over 2 times 12. So this first one, it's finding the area of the card. Okay. The area of that card, so we end up with 31.5. And if we stack 12 of those on top of each other, we end up with 378. All right, and we are talking units cubed here. Okay, so anytime you have a 3D prism, you can break it down. So there's the homework. If you have any questions, we'll work through it in class and talk about it then.